Hi, so this is Hobbyman 5000, and I have another update about the Alchemy AI, so feel free to check it out on the bitbucket. I've been working on it pretty much since the last video, and made actually some pretty significant progress on it. If I go look at it, so it actually has an AI in it now. It's just the initial AI step that was established in the notes, so it searches the first two sets of moves, the current move and the preview move that it gives you. So roughly like a human-ish. And I'm going to start running this in the background so we can have some fun scores going on and you can see how well it's doing or not doing, right? And what will matter is actually final score, not current score, which there's been a bug for, so 75k right there. That's pretty good. If you go look on like current week scores, that's up there in the top 25 or whatever, and I think if you look at, or ish. So anyway, so we're going to talk about all sorts of things that have to do with this. So we're going to go back to the AI. So I had mentioned that I was going to talk about heuristics this time. So any of you who don't know what that is, it's basically a way of saying that something is a good kind of estimate on how good your board state is. It's not necessarily a direct inference to the real goodness of the board state, but it's a way to kind of hint at somebody, that it's good or bad. So I made a bunch for this. One heuristic is don't lose. Losing tends to give you a worse score. Now, I actually had a lot of problems with this. I tried giving it a negative 500,000 point value, and I thought, that should be big enough. But for some reason, and I believe it had to do with latent board states, which I'll come back to, for some reason, it would sometimes choose to lose rather than not lose. And I played with that for hours. That was where most of my time was why is it choosing to do this suboptimal go for the loss? This suicide. So I ended up finding that it seems that the old load board state function without a clear board state function was leaving some kind of latent board state. I didn't actually figure out what that was, but it went from scoring 30,000-ish most of the time to 90,000-ish or 70,000-ish, and it got a high. One of the times I ran it, it got 177k, which is pretty good. That's actually reasonably a real high score that you could imagine somebody getting. And again, this is playing the harder version of the game. I could and actually should program it to play with the slightly easier version and see what type of scores it starts getting then, because it might actually start going insane. It might actually be enough just to do this. It might be that humans only consider these two variables and just bother with getting the most transforms that they can, keeping the most clear space that they can, and they don't even think about the next one, even though I tried to think about that quite a bit when I was playing it. Interesting. So one of the heuristics I used was, again, don't lose. Another heuristic sorry, cat's going crazy over there. Another heuristic I used was keep as many open, empty spaces as you can. And this has also been one that testing has shown very mixed results in. So I started with an insane value of negative 35, or plus 35,000. But basically that means every time you put a piece there, it's actually worth essentially negative 35k. Now, if I make it so you can't perform the losing moves, then these are still moves that you're going to perform anyway, and you're just going to take the ones that give you the most transforms. That's how I encouraged it, was the more empty spaces you have, the higher your game score is, even though that's not your real score. Now, that works to a degree, but it seems that when you bump that value up too high, for reasons I don't understand, but it starts aggressively going for transforms too much, I guess, and it tends to get lower scoring values. Although it's hard to tell because there's an order of magnitude variation in how it scores. Like I said earlier, it got 177k, and here you just saw one that was 22k. That's pretty That's a pretty huge margin. But it's a lot better than what it had. God damn it. It's a lot better than what it had been quite a while ago, which was earlier today when I was just starting the AI. I was fortunate to get the 45K mark, and then I had one really good one that was 120. So the best, there we go. That's not bad, 64K. So, alright, so that one heuristic was don't lose, another heuristic was as many empty spaces as possible, although I had some weirdness with that, and another one that I thought was pretty clever that didn't pan out so far, we'll go down to it, is this guy, right? Make sure that this didn't go insane. Good, 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 good. It's not allowed to perform losing moves still, that's pretty good. For a while it kept suiciding every chance it got, and I think it had to do with load board state not covering up something here and there, but boy was that annoying, because it would be halfway through a really good game and it would just kill itself. It was like, what are you doing? You have 5 moves at least left, and you don't even know what you're gonna get, you know. So anyway, the last heuristic that didn't work out too well was actually to encourage it to take matched pieces, to match pieces here and there where it would give it a few extra points. 92,000. Pretty good, pretty good, pretty good, pretty good. That didn't work out at all. I've even reduced it down to where it gets 1 point per matched piece for a max of 42. And it seems that that little bit of a bump encourages it to make bad moves. And I'm not quite sure why matching pieces in a matching pieces game is bad. It should still aggressively take transforms when they're worth 3,500 per open space, but instead this matched piece thing brings you down to about 12 to 30k, and it doesn't get much better than that. And I'm actually pretty stunned. I haven't figured that out, and I don't know if I'm going to. One of the problems with this search-based approach, I actually think you could probably get more information out of a neural net, because the search-based approach, when you have a problem, it is completely impractical to look at 500 board states. To look at one move, look at 500 board states, and then try and figure out why did you choose this one out of 500. You know, that's not going to work very well. It's just too much for the brain to really grab onto. So anyway, it becomes pretty obnoxious trying to figure out what the problem is when you seem to have validated all your functions and then things aren't working properly. It's killing itself midway. It has 24 moves before it would die, and then it doesn't take any of them. It just says, we're done. And so then you're playing with values, and the values don't seem to be changing anything, and anyway. So, I talked about heuristics. I talked a little bit about what it's doing. It's just searching the first 2 moves and using these heuristics to decide which of those moves seems to be the best one. Actually, another interesting heuristic I didn't use was the actual score of the game. Apparently, the actual score of the game, which is roughly going to be equal between all the moves, is pretty worthless. I tried adding it, and I think it actually made it play worse, and I think it's just because it's inflating the value in a weird way. Not sure. I guess whenever you add pieces to the board state, the reason it does worse is it won't take as many transforms that have point loss involved. So a transform that has point loss would be you have 4 pieces and you transform it into the next one. Well, that's only worth 3 times as much as the previous piece, so you actually lose a piece worth of value there. So it doesn't take early transforms very much. And so I think that's what was going on, is that when the game score went down, it discouraged transforms, and that's actually the best heuristic I have. Again, with the game loss thing, the game loss point value didn't actually work very well. I ended up having to make it so you're not allowed to make game loss moves unless it's the only move you can make, and that seemed to work a lot better. I thought just discouraging it would be enough with a score that's higher than most high scores, even weekly or monthly or whatever. But it's not enough, and so I just made it so it avoids them at all cost. And there's probably some time it'll bite me for 10,000 points or something, but that's chump change, right? So let's see, what else is there to talk about on today's changes since today? So I added a timer to it because I was curious the difference between debug, the difference between running, the difference between showing the text and not showing the text, and that kind of thing. And I found that there wasn't much difference at all between showing the text and not showing the text, which surprised me because sometimes your console applications are so clogging the buffer that they slow down in order to make sure that they print to the screen, or at least that's what I'm used to in C++. But in Python, it seems that it's efficient enough, or the language is inefficient enough that you can't tell much of a difference between printing the screen or not. So that wasn't interesting. The debug was, it looks like on my notes, it's about 4 times slower, so that was kind of interesting. But I guess the depressing piece that I'm at is until I figure out some ways to rewrap the loops and make everything a little bit more efficient, I have an issue where I'm only getting about 2,500 board states a second. Now that might sound pretty good, but we're again, if you remember the branching factor conversation from the previous video, later on, the branching factor is up to 1,100. Even if I choose only a couple of moves, we're talking that's already into the few second range. And if you wanted to do 2 moves after that, I would have to get 3 orders of magnitude almost of pruning. That's tough. That's 2 to the 10th worth of pruning about. That is unlikely for me to find that many things that I can make more efficient without trimming loops and figuring out a better way to load things, which we'll see what I can do in Python here. I was still having troubles with references. I was still having trouble with my load board state function. So the idea that I'm going to combine all these loops and they're going to work fine and not cost just as much time anyway is worthy of skepticism. It is a dubious idea. So anyway, we'll see what I can get it up to, because I probably need 1 million board states to get where I want, and I don't know. We'll see. We'll see. I'm actually a little curious if looking at the next move is going to hurt the ability for it to play well or not. There is a reasonable chance that it's going to take me days of programming to figure out how to get it so that when you look at the next move, you have the appropriate heuristic to take that information and apply it to the second move and apply it to the first move, right? Because frankly, there's a really good chance that it's going to go wrong, and for days on end. The fact that it's already getting 70k, 100k, these are reasonable scores. These are as good as I can do when I'm playing the first game, right? Because the second game is easier, like I discussed last time. I think maybe before tonight ends, I'll try to, god damn it, 15k. I'll try to test out the other way and see if it just scores phenomenally better. Because there's a pretty reasonable chance that it's just going to say, oh shit, here's shit tons of points, woo. But 117, not bad. But this is doing better than I can do as a semi-veteran of the game on the first game. And if it can do this well, maybe on the easier version it's already good enough. That would, I can definitely get to the third move search, which is something that I want to do so I can implement all that pruning for the purposes of resume fodder and nothing and things like that. But anywho, I guess that's my update for now. The next step is to revise some loops if I can to move on to the next bit of search and start some pruning techniques. So I guess I can discuss one or two of those before I get going. So one is called futility pruning. Basically, in chess, there's something by the same name, which is where I got the idea, where you get rid of moves that are obviously bad. So the moves that we do originally, I'm going to sort in priority order by points. And so all the ones that are worth pretty good, or possibly by ones that have high matches, although that's dubious now that the heuristic for matching didn't seem to work. But we'll see. Anyway, God, that bugs me. That should have worked. Anyway, so basically what we want to do is prune things that seem obviously bad. Take all the moves that we don't need out of that 484 that are just worse than all the others. You know, take only the ones that are the highest board score value. Whatever we do, whether that means that we actually go back to the matching technique or not, we take all the ones that are of that highest caliber, right? And we then pass those on as the next ones. Now, we don't want to do only one move, because if we do only one move, we already have the one move that we're going to do way up here, right? If we have one move up here, and all of the other moves stem from it, may as well stop. So we actually want to get the top couple of moves from move 1, and then the top couple of moves from move 2, and then the top couple of moves from move 3, if we can get there. But that should be an interesting problem to figure out how to do. So this futility pruning is getting rid of all the obviously bad ones. So the ones that don't score very well. Let's see here. Another bit of the futility pruning was to, once we get to subtrees, if they all look bad, if they're not looking pretty good, we're not going to search down them. The idea there is just, why bother? You know, that's gonna be a little difficult to navigate, I think. But basically, we have to chop so much out in order to get to move 3 and move 4. Given that I'm only getting 5 moves a second right now, and so let me explain that for a second. So if I'm only getting 5 moves a second right now, that means I get 15 moves in about the time frame that I'm actually looking at. So I want to move a second, or a move every 3 seconds or so, at least for the purposes of playing kind of like a human, right? So if I want it to be that fast, that means I really only am dealing with 15 moves right now. That's bad. That's not too good. That's only $7.5 grand worth of board states I'm checking. This is 3 orders of magnitude worse than I was expecting. At least 2 orders of magnitude. And so, big deal to try and figure out ways to prune stuff. Let's see here. Another idea I had, this is only going to save me 10% or so it's, I'm not sure if it's even worth trying out, but there's the idea of pessimistic pruning. So there's, when it comes to the 3rd move, and later, we don't actually know what the pieces are, so pieces that seem a little bit too fortuitous for us, that are just really easy to figure out later, there's no reason to figure them out now. We don't need to prepare for those now. We need to prepare for the moves that are mediocre or bad. And so what we want to do is get rid of the double moves that happen to line up perfectly with our ready transformations. So any of those that are super close to being a perfect move in the first place, we're not going to search down those, because we're going to choose those obvious choices later. And That was another one. Let's see what else we got here. Pessimistic protein transformation. I've definitely considered doing a database, but the database grows so fast due to that branching factor. We're talking e, basically 10 to the 42nd power, 10 with 42 zeros or whatever, number of board states just for 10 piece types. It's an absurd number. And now, this doesn't take into the account reflection board states or board states that we could emulate by pretending they're all worth a piece less or a piece more, given that we're just worried about transformations and things. So that might save it, but I think it's going to take writing a program to estimate the number of board states that actually matter before I can even start considering building a hash table. It just seems too completely unreasonable to build a hash table when you're looking at such gigantic numbers. And again, just look at the order of magnitude discrepancy in points variation. Like, let me run this again. So it just got 117. Won't surprise me if this stops at 20k. That's, or 17k or whatever. It can easily die out on the basis of bad rolling, so to speak. So, 50k, that's not bad. But again, it's using the exact same deterministic search pattern. This isn't even with a random search pattern yet. Or this isn't even with a search pattern that has unknown information. This is deterministic. And the game has enough luck in it that the game has enough luck in it that it's gonna take a lot of testing to really get from point A to point B. Let's see, is there anything else that matters yet? I don't know. I think it's gonna be an interesting ride here, but I'm not really sure how much more I can do for it at this point. We'll play with it for a week and see where we can get. So until then, cheers.